So we are moving on to our third session for the platform stream. Again, my name is Rebecca McDonald and I'm the People Operations Manager for our core business operations team at Deloitte. So it gives me great pleasure to now introduce Marco Palladino. Marco is an inventor, software developer, and internet entrepreneur focused on designing and building products at Kong with deep passion for APIs and microservices. He's the co-founder and CTO of Kong and is joining us live from San Francisco today. So Marco is going to be talking to us about how to achieve zero trust security with Kuma Service Mesh. Welcome, Marco.
Hi, Rebecca, and hi, everybody. I'm here in San Francisco. It's 6:20 p.m. here. I'm very excited to speak about zero trust and service mesh.
Fantastic.
Yeah. Well, I'm the CTO and co-founder of Kong. You may know Kong because we provide connectivity software that spans from API gateways to service meshes and ingress controllers. We also have quite a large footprint in Australia and, quite frankly, worldwide. We power important industries. The finance and banking industry in Australia is their customers, the top 4, top 5 financial institutions, customers of Kong. But we also operate with travel, e-commerce, technology organizations from Australia and all over the world. So today, I want to chat about Zero Trust. And I want to explain what Zero Trust is, describe the pattern, and then look at a practical demo of Zero Trust applied with Kuma and Kong Mesh, with Service Mesh, across multiple clouds, including Kubernetes and virtual machines. So I'm actually going to fire up the terminal, and we're going to be seeing a live demo of the product. Well, obviously, our teams are going to be creating more and more applications, and with them, more and more services. Whenever we create more services, and thousands more are going to be showing up in our architectures moving forward, we want to make sure that these services are always protected, always secure, and we want to make sure that all of these is being provided by the underlying infrastructure. The more services we create, and the more challenging it is going to be for the application teams to provide this uniform and consistent security layer across all of these applications. Instead, they rely on us, the platform architects, to provide that for them. We want the application teams to be consumers of these security. We don't want them to be the builders of these security. And of course, the more services we're going to be having in the future, and the bigger this problem becomes if we don't address it early on. And so let's talk about Zero Trust. And really, in order for us to understand what Zero Trust is, we must understand why trust is a bad thing. Trust is bad because it's exploitable, and we must remove the concept of trust from our systems. Imagine entering a new country without a passport, and the immigration officers would essentially have to trust that we are who we claim to be. And sooner than later, somebody will exploit this trust, and a lying criminal will enter the country illegally. And since trust is exploitable, we must remove it. Zero trust intended as no trust. And so this is why when we enter a new country, we must present a passport. The passport allows us to verify our identity in an undeniable way, in such a way that the immigration officers really know that we are who we claim we are. And likewise, when we travel, we have a passport. Our services must also present a virtual passport, if you wish, to other services when they make a request, to make sure that they are indeed allowed to execute the operations they want to execute without having to rely on trust. We cannot just trust that we receive a request, and that request, we cannot trust it comes from an allowed service. We cannot trust anything about that request if it doesn't come with an identity. This virtual passport is hard to generate and validate across every service the teams are creating, unless we use a service mesh. And we're going to be seeing how we can use Kuma and Kong Mesh to provide these underlying trust infrastructure, zero trust infrastructure to our services that automates the entire process for us. And the process, it's quite complex. We must issue identities for our services. We must check those identities to make sure that they're valid. And then we must create permissions, propagate those permissions, and check on those permissions every time we create a new service. In the real world, the identity is being provided by a paper passport. But in microservices, this identity is being provided by a TLS certificate. If we use Kuma and Kong Mesh, and a service mesh really, we are going to be able to provide this underlying infrastructure in one click, literally one click. And I'm going to be showing you this in just a few minutes. And once we do it, boom, everything is secure, everything is encrypted, and everything has an identity, and we're ready to go. Our teams can create new services knowing that that identity infrastructure will be already provisioned to them. We get secure and compliant out of the box automatically. So we need virtual passports for our services. And let me tell you why with a more practical example. Let's look at a monolithic application, for example. This is a marketplace application like Amazon. You know, every resource that we create can be accessed indiscriminately from every other resource via a function call, since they're all part of the same code base. And typically, our resources are going to be encapsulated into objects, if you use object-oriented programming, that will expose initializers and functions that we can invoke to interact with them and change their state, among other things. To give a simplified example, if we are building a marketplace application, like the one we're seeing on the screen, we're going to be having resources that identify our users and the items that we're selling. And once we sell the items, we're going to be generating invoices and so on and so forth. This means that we're going to be having objects that we can use to either create, delete, or update these resources via function calls that can be used from anywhere in the code base, since they are all part of the same monolithic application. And while there are ways to reduce the visibility and the access of certain functions and objects with, public, private, protected access level modifiers, package level visibility, and so on and so forth, well, typically these practices are not strictly enforced by the teams, and everything is one PR away from being disrupted. In a monolith, the good mindset to adopt when thinking about our resources, it is that essentially everything can access everything else. And whatever access modifiers we have in place, those are very easy to change. They can slip into our code base in such a way that we don't notice. So with microservices, instead of having every resource in the same code base, we'll have these resources decoupled into separate services, each one of which can expose an API that can be consumed by another service. This means that instead of executing a function call to access or change the state of these resources, we can execute a network call instead. This is great. Our resources can now interact with each other via service requests over the network, as opposed to function calls within the same code base. The APIs can be RPC-based, they can be REST-based, HTTP, they can be really anything. But by default, if we don't do anything else with this doesn't change our security posture. Effectively, without any barrier in place, every service can still consume the exposed API of every other service. And by doing so, they can change the resources and the state of those resources, even if they are not supposed to do that. But there is one thing that we are introducing here, and that is the network. The medium has changed. Therefore, we can use technologies and patterns that operate on the network level to secure our application. Moving to microservices and then using a service mesh to implement zero trust security is a chance for us to improve our security posture as opposed to monolithic applications. We can make our systems and applications more secure because we can be more fine-grained in how we apply these resources on the network level. In order to determine security rules over the network, we must do two things. Number one, we must set up those permissions, and then we have to check for those permissions. So we may want to allow invoices and users to consume each other, these two services. After all, an invoice is always associated with a user, blah, 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 but only allow the invoice service to consume the item service and not vice versa, like the following scenario we're seeing here on the screen. And this check could be done by the services themselves or by anything else that's on the execution path of those requests. But it has to happen somewhere. If nobody checks for those permissions, that permission does not exist. But here comes the biggest problem of all. Before we can even think about enforcing any permission that we want to create, as a prerequisite, we must have a reliable way to assign an identity to each service so that we can identify the services that are making these requests. And then based on that identity, we can verify that they are who they claim they are and then implement the right permissions for them. If there is no identity in our infrastructure, it doesn't matter how many permissions we create. Those permissions are going to be unreliable. The identity verifies that the service really is who they claim they are. Without identity, there is no security, essentially. And in order for Zero Trust to be implemented, we must assign an identity to every service instance that will be used for every outgoing request. The identity will act as a virtual passport for that request, confirming that the originating service is real and it's the right service. Mutual TLS can be adopted to implement Zero Trust, and mutual TLS gives us two advantages. We can not only assign an identity to our services, but we can also encrypt the traffic between the services. And then once we have that identity in place, we can enforce our permissions with peace of mind. The identity of a service can be assigned in a SAN. SAN is a subject alternative name of the originating TLS certificate associated with the request. So essentially, we would have the service name as an additional SAN field in the TLS that has been provided to the services in such a way that then all of these TLS certificates will be generated by the same underlying certificate authority in such a way that when a service receives a request, they can decrypt the certificate and then parse that SAN field and determine the name of the service. And then based on that name, we can enforce permissions and rules that in the meanwhile we have created. SAN is an extension to X509, which is the standard that is being used to create public key certificates. This is an example of SAN fields from google.com that we can fetch if we inspect the certificate that Google is associated with, with the domain name. Well, so how do we do all of this? Sounds complex, because it is complex. We have to generate the certificates. First and foremost, we have to generate the CA, issue the certificates, rotate the certificates, expire the certificates. There is a whole life cycle that we have to take care of. Then we must enforce the permissions, and we must be able to do that across Kubernetes, virtual machines, across every application, no matter what. Service Mesh, it's a great medium to implement the Zero Trust security solution for our teams. Service Mesh per se, Service Mesh allows us to implement many different use cases, among them Zero Trust. It is not an end per se. Service Mesh, it's a medium to an end. So that's very important to understand. It's a Swiss Army knife that we can deploy to provide, among other things, Zero Trust security to our teams. And of course, today I'm going to be talking about Kuma because it is a neutral service mesh, the first in the industry that really took portability seriously by supporting natively virtual machines and Kubernetes and hybrid workloads across one cloud or multiple clouds in a native way. With other service meshes, VMs is an afterthought. They're not supported well. Distributions, multiple clusters, distributed environments, multi-cloud, it's not supported well. Hybrid, it's not supported well. And perhaps this is going to be the first demonstration you're going to be seeing of a hybrid VM and containers, multi-cloud, multi-cluster service mesh. And we're going to be implementing Zero Trust in one click in just 1 second. So with Kuma, we can, of course, Kuma is a control plane. It leverages Envoy proxy as the underlying data plane proxy technologies. It is built by Kong, but has been donated to the CNCF Foundation. So it was actually the first Envoy-based service mesh to ever be donated to the CNCF Foundation. It's open source, it's portable, it's extensible, it's easy to use. Simplicity is a feature in service mesh. It is very complex to deploy typically, but with Kuma, we made sure that would be as easy as possible. It's growing quite fast. We have over 1,000 organizations using service mesh with Kuma and Kong Mesh. Kong Mesh is the enterprise supported version of Kuma that Kong provides. It runs on Kubernetes, VMs, multi-cloud. It's single and multi-zone. It's multi-mesh, so we can deploy one cluster of Kuma to support as many meshes as we want in order to support as many teams as we want, as many applications as we want. We provide native policies that are one click away for fault injections, for routing, for healing, self-healing, for zero trust security, and all sorts of things. It's built to scale, provides first-class support for containers and VMs. It's natively distributed across one cloud, multiple clouds, one cluster, multiple cluster, or a mix of all of them. When we look at the zero trust security feature set, well, there's a lot to unpack here. Zero trust is only one of the many features that Kuma provides, and it supports many different types of certificate authority backends. It supports lifecycle of both the CAs and the certificates that we're issuing to the data plane proxies, encryptions. It supports OPA out of the box. It supports all sorts of different mesh compartmentalization strategies that we may want to implement by using the virtual mesh resource that Kuma already provides. It is quite comprehensive, and this works either in one cluster or multiple clusters out of the box, thanks to the quite unique architecture of Kuma with a global and remote control plane separation. There's a GUI out of the box, there's a CLI out of the box, there is an API out of the box, native Kubernetes resources out of the box, policies that we can adopt for all sorts of different use cases, as well as out-of-the-box dashboards and service maps and service topology views for our services. Applying Zero Trust with Kuma is quite simple. We're going to show it in a couple of minutes. It's one resource, so we can, for example, here, update the default mesh to support a built-in certificate authority, which means that we're going to be creating the certificate authority by ourselves automatically, but you can also provide your own certificates. You can also integrate with HashiCorp Vault. And we're going to be rotating our certificates every day. And it doesn't matter if you have 1,000 or 100,000 of data plane proxies running around. This is the one policy we need to manage that entire life cycle. It's one click away. And then once we've done that, we can use the traffic permission policy to determine what services can consume other services, and we can use Kuma's tags or attributes to make that happen, like the service name as we're seeing here. So this is a traffic policy, a traffic permission policy that allows every service to consume every other service. But we can also restrict that by region, by cloud, by zone, by version. It is quite comprehensive. And then with Kong Mesh, we can also support OPA without requiring an extra OPA agent running in an extra sidecar. We bundled the OPA agent within the same sidecar that runs Envoy in such a way that we can then provide OPA to the teams out of the box, and not only secure with Zero Trust the identities and the permissions of our services, but also the out N and out Z policies for every application. It is quite comprehensive. So let's look at the demo. It's going to be a very quick demo. Right now, I have my demo environment running on multiple Kubernetes clusters, as well as I have the same mesh spanning across multiple clouds, including EC2. And so if I look at my Kong Mesh clusters, we can see that these are EC2 virtual machines that are also providing the demo application and the control planes for this zone. So let's very quickly, let's expose the GUI so we can see what's the status of my mesh. I'm connecting to the global control plane, which is the primary control plane, and I'm going to be port forwarding the control plane in such a way that we can access the underlying GUI. It is quite straightforward. So now I can access the GUI. The GUI is built on top of an API, so we can automate everything that the GUI can do. We can also automate. We do have 3 different zones on AWS, EC2, virtual machines, and containers on GKE, East and West. We do have a few services. We do have our demo application, which will increase a counter in Redis. And we do have all the data plane proxies displayed here. And we have all the policies here, like, for example, traffic permissions, which in this case is the one that allows us to consume every service. So today, if I access the demo app without ZeroTrust security, we're going to be restricted in the same zone that we're consuming the front end from. So we're consuming the front end from EC2. Therefore, we can only increase the Redis counter on EC2. But let's go ahead and implement ZeroTrust security. So let's go to the policies, open up mutual TLS, and then fetch our mutual TLS policy, which will secure our default mesh with a very simple ZeroTrust policy with a built-in certificate authority. And if I create my command, my Kubernetes resource, I can apply my Kubernetes resource. And I want to show you what happens here when I do that. I can apply it. Global control plane. The global control plane will propagate that to the remote control planes. The remote control planes will provision the CA. They will issue a new certificate for our data plane proxies. And just like that, we have ZeroTrust enabled across multiple clouds, VMs, containers, multiple clusters. And not only that, we also have cross-zone communication out of the box. So our virtual machines and containers are operating as if they were running in the same cluster. And if we go back to the GUI, we can then see the mutual TLS enabled. And for each proxy, we can see the status of our certificates. As a matter of fact, all of these certificates were issued half a minute ago. One click, and this is how easy it is to implement ZeroTrust with Kuma and Kong Mesh. All right, so we looked at the challenges of having more and more services. We have to have a security layer that the teams can consume. We looked at ZeroTrust, and we also saw a demo of Kuma to implement in Kong Mesh to implement ZeroTrust. You can learn more about Kuma at kuma.io. It's free to use, and if you want to look at an enterprise-supported version of Kuma, you can check out Kong Mesh on konghq.com. Thank you so much.
Thank you so much, Marco. Now, we do have some questions coming through. So the first one is from Eric. Eric has asked, how would you compare different approaches to achieve zero trust? For example, MTLS, ZeroAuth, and Open Policy Agent. And then how does Kuma support these approaches?
These approaches are complementary to each other. So we want to create an underlying certificate provisioning infrastructure so that we can assign identities and encrypt the traffic. And we need to have what I just showed in the demo, the TLS provisioning, the CA provisioning, and all that goes with it. And then once we have the identities, we can assign permissions, or we can leverage OPA to create more sophisticated permissions and rules on top of those identities. So we need to have the certificates, we need to have the identities, and then once we have that, we can be less or more sophisticated depending on what the use case is. With Kuma and Kong Mesh, the easy part is that we support all of them. And as a matter of fact, when it comes to OPA, Kong Mesh is the easiest way to use OPA. We have a partnership with Styra, which is the enterprise organization that the OPA creator also has created. And we're working with enterprise customers around the world to deploy OPA across every application. But because this is also supporting virtual machine as a first-class citizen, it's not container only. It's not Kubernetes only. It can be also VMs. We do have customers that are deploying service mesh, Kuma and Kong Mesh on VMs only with no Kubernetes dependency whatsoever. So they're complementary use cases.
Great. Thanks, Marco. Also, we've heard a fair bit about service meshes this morning. Why would a user or a customer choose Kuma and Kong Mesh versus other service meshes?
Yes. Well, so Kong created Kuma because the other service meshes didn't work for us. Otherwise, we would have gladly used other service meshes to provide the things that we provide. Other service meshes are hard to use. They're hard to scale, hard to upgrade. They suffer from deep-rooted problems when it comes to scalability and supporting multiple thousands of data plane proxies. Some of them are not supported more than 2 versions in the past. Some of them are not supporting VMs the right way. As a matter of fact, I gladly showed a VM demonstration with containers. I don't know how many demonstrations like this anybody has ever seen, because they don't really support them. Whereas this has been built to support VMs and containers as first-class citizen. It's distributed by default. It supports OPA by default. It supports different PKIs for Zero Trust that others don't support, for example. So there is a comprehensive set of features that other service meshes don't even provide. And this is a CNCF project. So we strongly believe in open source and cloud portability, but most importantly, on project neutrality when it comes to these foundational technologies. And Kong, the vendor, we're one of the contributors to Kuma. There is others. We also provide a full stack platform that includes the Kong gateway, which is the most adopted API gateway in the world. So we integrate the gateway with the service mesh in a seamless way in order to be able to take care of the full stack end-to-end, north-south and east-west connectivity for every team out there. And that conveniency of working with Kong, it's something that has been very valuable to some of our customers.
Great, thanks, Marco. You can just see the passion oozing out. I love hearing you speak. It's great.
Thank you, Rebecca.
All right. Well, that brings the session for this morning to a close. So thank you so much, Marco, for joining us. And we'll let you head back home now at the end of the day. All right,
Thank you.
folks,